All right, we already talked about the basics of electrostatics. So now we're going to talk about what happens when charged objects actually start interacting with non-charged objects and how do we get electrons to move between them and things like that. So the first thing on the list is to understand conduction. Now, conduction is when you charge something through contact. You have to have physical contact. And when this is done, you get the same charge for both objects. So here I have an example. I've got a neutral sphere and a positive cube. So if I want to have the excess electrons or electrons in general just pass between these two, then I basically have to connect them with some sort of wire. What this does is it allows the electrons to pass between them because it's all conductive materials and electrons can flow through the conductive materials. So now all objects want to have basically the same charge. Everything wants to spread out evenly. So if I do a head count here, this has a charge of 0. Because we have the exact same number of electrons and protons, 3 and 3, so our result is 0, thus we are neutral. Over here, I've got 5 protons and only 3 electrons, so therefore I am at a 2. Well, these want to spread out, so if you do 0 plus 2, you get 2. 2 divided by 2 is 1. So what's going to happen is we want to have 1 in each. That's how it's going to balance out, because it always wants to balance out evenly. So if I look to what's going to happen, the electrons are going to rearrange to get this. Well, what that means is I'm going to take one electron and it's going to move from here over to here. So that guy's going to go away and he's going to appear over here. Boop. So now if I do a new head count, then I have a total charge of +1. And over here, I have a total charge of +1. So we went from neutral to positive. So I'm now positive, and I'm still positive, but not as positive as I used to be because I gained an electron. Okay? If it was negative, then we would have had electrons transferring from it to the neutral object, and the neutral object would have become negative. So all you have is electrons passing around with conduction. All right? That's the most basic one. Now the interesting one, though, is when you charge with what's called grounding. All right, if you charge by grounding, then there is no contact with the charged object, and you end up getting the opposite charge. Now this involves a few more steps. So if I charge by grounding, then I need to have multiple objects involved. All right, so let's draw those objects. Okay, So first of all, I have to have an object. Oh, let's go with a cube again. That was fun. And it has to be grounded. So what this means is it's connected to the Earth or some very massive object that can either give or receive as many electrons as it needs to. All right, and then we'll have another object. We'll do a sphere again. That's not a bad circle. All right, so I always start with the positives because the positives never move. All right, so here we go. So what happens is if I have this charged object, I actually have to have a third object in between. Let's have a third object. I'll make you a rectangle. Why not? All right, All right, so this time I'll play with negatives because I've been playing with positives for a while because people have a hard time swallowing or understanding that positive thing. So let's make this super negative. All right, super negative. It's had a bad childhood. It's just angry about everything. It's just super negative. This we will have starting off as neutral. 3, 4, 5. And this is also neutral. It's grounded. It will basically always be neutral. 3, 4, 5. There we go. All right, so now here's a series of steps. When this negative object is brought near this, we have that polarization where the negatives are going to move in this direction. So they're going to kind of fill up on this side. But if I've connected it to ground, all right, so let's connect it to ground by drawing some wires. All right, so I've connected it to ground now. Then those electrons can run farther away. Instead of just running along this edge, those electrons can actually run all the way through the wire. So they'll go all the way through the wire. That's supposed to be red. What is going on in this world? they can run all the way through the wire and into the earth. And so what that means is they're going to leave here. So that's kind of like step one. Step two is we then break our contact with that. And so those electrons that left, got to make those positives again. Those electrons that left are now gone forever. Oh no, they're gone because the electrons left. And so now the overall charge of this is positive because the electrons have left us for good. Now notice how there was no contact between the two, but we did have to have contact with the ground. So those electrons could go from our object. Basically, in this case, the electrons were scared away all the way into the earth. And so now when we remove that piece, before we remove this, then they are trapped in the earth and we have a positively charged object. If this was already positively charged, then the exact opposite would happen. Electrons, and if this was, this is positively charged, then electrons would have run towards here because they would have been attracted to the positive. And then if we removed that bridge, they'd be trapped here, and then this would be negative because it had excess electrons. So either way, it's getting the opposite charge, and that is charging by grounding. No contact with the charged object. It always gives the opposite charge of the charged object. All right? Those are the two main methods that we're going to talk about charging different objects in electrostatics. So I hope that was fun. See you later.